Hi folks, we're going to take a look at number 15 from page 507. So they give us this system of equations and they want us to determine when it has no solution, infinitely many solutions, and exactly one solution. Okay, so we're going to have to determine the values of k that are going to give us that. So let's consider the first two options. In order to have no solution or infinitely many solutions means that these lines have to be parallel. Okay. And in order for them to be parallel, we need their normal vectors to be parallel. Okay, so here we have a normal vector of 1, 2. And there we've got a normal vector of 2k squared. So we need, essentially here, we need n2 to be equal to some multiple of n1. And it's very clear by looking at the x components that this p-value has to be equal to 2. Okay? So that means that 2 times 2 has to be equal to k squared. Okay? So here we need 2 times 2 to be equal to k squared. So that means k squared is equal to 4. And so k can be equal to, and folks, please do not forget, we're taking a square root. So it could be equal to positive or negative 2. Okay, so these are the two scenarios that are going to give us parallel lines. Okay, now in order for them to be the same line, we need this c value, which has been brought to the other side of the equation, to have the same multiple as the ones in the normal vectors. So here we would need 2 times negative 1 to be equal to negative 2. Okay, this is what would make these two lines equal. So what we have is that for A, if we need no solutions, so we still need them to be parallel, but I can't have k being equal to negative 2. I need k being equal to positive 2. So this k value is going to make the two lines parallel, but is going to make these c values have a different connection. Okay, so again, we already said that in order for it to have infinitely many solutions, the two lines have to be the same. So here the k value has to be equal to negative 2. So again, makes it parallel, and the same scalar multiple gives you the other c value. Okay, so what's going to give you exactly one solution? Well, essentially, any scenario where these two lines are not parallel, they're going to have to intersect at one point. Okay, so here k can be any real number except 2 and negative 2. Okay, so what did we use to solve this problem? Just to recap, is we use the fact that in order for a system of two equations and two unknowns to have either no solution or infinitely many solutions, they have to be parallel, which means these normal vectors have to be parallel or scalar multiples of each other. Okay, if they're to have infinitely many solutions, the c values have to have the same scalar multiple between them. No solution, they do not. And then any scenario where these two lines are not parallel, that's going to give us one solution. Okay, that's it for this one.